Hello everyone, this is Professor Maloney. Today I'm going to be creating a recording to sort of mop up or finish modules 3, 4, and 5 at the MindTap site for our class. So I did a video 2 days ago that was for modules 1 and 2 in Computer Concepts, and this one will be modules 3, 4, and 5. You have until Wednesday, I believe it's Wednesday the 7th, to finish your, Wednesday the 7th, to finish your 5 quizzes from modules 1 through 5. And then, the class sort of picks up speed with Windows 10, but not that much. And then the following week, starting on the day of the Windows 10 exam, which is, I believe, the 13th, make sure here. Yeah, the 13th, that's the day that you start Microsoft Word trainings and projects, and that's going to be, where you're going to be very, very, very busy. So try to take care of these module quizzes. Remember, you get 2 tries on each, so try to do them 1 time each, this weekend, ideally. Labor Day is a holiday, so just for Monday, Wednesday students, or Monday, Wednesday, Friday students, next Monday is the 5th of September. That's Labor Day. You do have class with me on Tuesday the 6th of September. And then Thursday the 8th, I'm going to change my class to not be a required live class. I'll just have a video out there telling you what to do with Windows 10. It'll be a Windows 10 video, actually, demonstrating the training. And I'll just tell you, make sure you do this 3, 4, 5, 6, even 10 times between the 6th. Let's see. Well, no, sorry. It's going to start on the 8th. It'll be available on the 8th, and then you have until the 12th. But there's only 21 tasks. So the more times you do them, the easier it will be for you to get a 100 on that Windows 10 exam. And remember, all exams in here are worth 10% each off your final class grade. All right. Okay. So let me take myself off the picture here and share my screen, and then I'll go over. And I'm not going to make this video long. I know many, many times I say that, and it ends up being a little bit longer than I want. But I'm going to try to make this thing here. Let's see, I'm sharing my screen. I've got my video capture on the computer. All right. I'm going to try to make this thing about 45 minutes. And thus far, it's probably, about 2 minutes so far. Let's say 3. So I'll try to finish it at 12:43 or so p.m. And I may be able to make it faster than that. Who knows? All right, let's see here. I'm going to go to Student Start here. And students click here to go to MindTap. Some of you know that yesterday the MindTap site started to act up, but it is perfectly a-okay again. All right, so Technology for Success, Computer Concepts. Let's see how many of you have done it or them so far. Okay. All right. So module 1. Let's see. Well, 9 out of the 15 in the class. So that's 2/3, or not quite 2/3, but either way, it's 60% of the class has finished that. Okay. So it's 3/5 is what it is. 60% of you have finished that with an average grade of 92.3%. That's excellent. If I recall, it was 5 of you, and it was 91%. So now 4 more have come in and improved the average a little bit, but it's still in the A category, which is great. Module 2. Let's see, quiz. 4 of you have done it. I believe the other day it was either 1 or 2. If it was 1, I think it was 100. I think it was 1 and it was 100%. So now 3 others have done it. It's come down slightly, but it's still a great average, 97.8%. And obviously then module 3 is probably, okay, 1 person and 100. Great job by him or her. Module 4, 1 person. Great job by him or her. And module 5, none. All right, so that's all A-okay. All right, so as I did the other day with modules 1 and 2, I shall talk a little bit about these sections. So I'm at the MindTap site. I'm going to use the full book, but I'm also going to use what we have here. So I'm going to go to module 3 first. So module 3 is computer hardware. All right, so what is computer hardware? Well, your monitor, it is hardware. Your case, if it's a desktop, is hardware. Any cables are hardware, any chips, any cards, anything that's physical, that's hardware, okay? So that is what this chapter is all about. So let's start with just a real quick little thing on the introduction and how many objectives there are, probably not more than 7 or 8. All right, so in this module, categorize the various types of computer hardware, demonstrate familiarity with input and output devices. So input devices, what would be input devices for our computer? Well, obviously, we typically do it via, we're typing, right? But sometimes we also input via pulling up a file. Like you can have an input from a Microsoft Word file, Microsoft Excel file. Literally, you can have obviously input from a program, but those things. But keyboard would be the normal input, okay? And then for output, obviously 2 big ones, printers and your screen. The screen is number 1 and printer would be number 2. And then maintaining hardware components, well, we're going to obviously be talking about making sure that we protect our devices, make sure that we occasionally clean our keyboard as an example. They have nice little cans of air that you can spray to clean those things. There are also cleaners that are specifically made for computer keyboards, also for screens, so that it doesn't damage those components. And then, of course, if you're using a desktop, that's what I was mainly talking about. But that would also apply to if it's a laptop. If it's a tablet, it's obviously smaller. And if it's a smartphone, it's smaller still. But they still have the same components in terms of they do have a screen. They do have the ability to input via typing on the device itself. The output goes still to the screen, and the input comes from what we're typing or what we're loading into memory. So smartphones we use quite regularly these days. I may have mentioned the other day that, literally all of our phones these days are more powerful than a mainframe computer from 6 or 7 decades ago. So meaning if we went back to the 1950s, let's say, mainframe computers were 30, perhaps even 40 feet long. So imagine a computer that long, and they were less powerful than our phones. And they ran companies. Everything was run from mainframes way back then, right? So that's that. All right, so this is just the objective right there, all right? And then if we go to the next, remember it's going to be videos on occasion. Looks like some of you, 2 of you have done this. Let's see how long the video is, just again to give a little bit of an idea. I'm not going to be going through most of these things, but I want to make sure that you're aware. As always, I'll tell you that when you get something like this, that's a pop-up, right? This pop-up is just playing a video, but there will be pop-ups when you're doing your training, and those pop-ups and doing your exams, those pop-ups then will emulate the thing you're being trained on. So that will be Windows 10 starting on the 8th of September and going to the 12th, and then Word starting on the 13th and going for about 3 full weeks. Anyway, all right, so let's see how long. Oh, it's 2.5 minutes. So I'll just play a minute or so of it. Let's just to see, and if I like it, I'll let it go.
Computers represent data. Whenever you type at a keyboard, draw with a mouse or digital pen, or swipe across a touchscreen, what you're actually doing is providing input that your computer stores as binary data. That data isn't made up of words or drawings. It actually consists only of 2 numerical digits, 1s and 0s.
So 0s and 1s is the base 2 system. That's what computers use, as she just stated. They're comprised of just a ton of 0s and 1s, and that's literally input. I'm sharing my, let me verify again. I'm sharing my screen. Let me come over here and just do this little thing here real quick. Where am I? Over there. I am, where I am now. Silly me. Anyway, I'm at MindTap, and I played a video. Where is the video? Did I shut it down? We'll assume I shut it down, and I'll just do it again. All right. And you know what? Instead of doing it again, I'm just going to go ahead and show you. So I'm going to open up a notepad file. All right. So let me go over here and say note. All right, a notepad file. So this notepad file I'm going to show you how you can convert characters into those zeros and ones. So I'll do the capital letter A. So capital letter A in the ANSI world, which is the American National Standards Institute world, represents the number 65. And then a little a represents the number 65 and 26. So 65 and 26. It's about, I guess, 91. Actually, be one more than that, so probably 92. I'll just put 92, but I'll go online to find the actual values. All right. So the reason I'm saying this is because what they were showing you was all these zeros and ones. So if you type a big A, it's this A equals 65. But here's what the computer sees it as. A equals 0, 1. And then 1, 2, 3, 4, 5 zeros and a 1. Okay? And make it, you know what, I think this is actually a 96. Yeah, I may be wrong, but I think the little a is a 96. So I'll do a little a based on that number. If I'm wrong, then obviously the calculation will still be right, or the output will be right. It's just the number, I may have to change the zeros and ones to change it for the new number. So at 96, it would be a 0 and a 1 and a 1, and then a bunch of zeros, 1 and then 1, 2, 3, 4. So that, all right. Now, how did I do that? Well, so now I'm going to show you something else, and then I'm going to go online to find out what a capital A and little a really is. So everything we type, the capital letter A, the little a, if you type the space bar, if you type the number 1, you type R, you type anything on your keypad, okay, it represents 1 byte in the computer world. And 1 byte is represented by 8 bits. So these 8 bits here represent the capital letter A, and these 8 bits here represent the little a, assuming the values I wrote up here are right. If that big A is a 66 instead, then this 0 here would be a 1, and this 1 here would be a 0. But I'll show you how that works right here. So here's what we do. We start with what we call the most significant bit out of these 8 bits. So that's 128. And then you take half of that, that's 64. Then you take half of that, that's 32. Then you take half of that, that's 16. Half of that, that's 8. Half of that, that's 4. Half of that, that's 2. Half of that, that's 1. And then you put or 0, because the 1 could be a 1 or a 0. Okay? And that what this means is that no matter what number I have, I can find it here from, and I'll show you how I'm going to do this in a moment. I can find it here by just putting up zeros and ones, and then the value left will always be a 0. So watch, let's do it with the 65. So I did the 65 right here, but here's what I did to get it. I said, how many times, or can the number 128 go into 65 1 or more times? In other words, is 128 smaller than 65 is what that is asking. And of course the answer is no, because 128 goes into 65, but it would be going in with like a 0.51 or so. Okay, so this bit down here will be a 0. So I'll go down again. So I'll put here 0. Okay, now can the number 64, which is the second one, go into 65 1 or more times? Well, 64 goes into 65 exactly 1 time, but then there's 1 remainder. So the answer is yes. So it's a 1. And you see up here, I put a 0, then I put a 1. So now out of the 65, we've used 64. So there's 1 remaining. Okay, can a 32 go into 1 or more times? And of course it cannot, right? So that's a 0. It's off. Can a 16 go into 1 or more times? Of course not. Can an 8 go into 1 or more times? Of course not. Can a 4 go into 1 or more times? Of course not. Can a 2 go into 1 or more times? Of course not. Can a 1 go into 1 or more times? Of course. So it's a 1. So then you add them up. This is a 60. So the ones with ones you want to add up. So we have 64. This one is 64. So we go over here and take 64 plus 1, because this one here represents this one, equals 65. Okay. Now for the other one, the little a. So can 128 go into 96 one or more times? No. Can 64 go into 96 one or more times? Yes. So it's a 1. Can 30 now? So now 64 up to 96 is used. So there's 32 remaining. This is what a computer does, by the way, but it does it instantaneously. And because I teach A+ hardware, I can show you how to do it. But this is, very, 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 very slow. And of course, part of the slowness is because I'm showing you guys this. But anyway, so you take 64 away from the 96 because the 64 is on, meaning it went into 96 one or more times. So then you take 64 away from it. There's 32 left, ironically. And what is 32? Can 32 go into 32 one or more times? Of course it can. It goes into it exactly one time. So what's the remainder? 0. So that means the other digits in this case are zeros. Okay. And then over here, so the 64 is on, it's a 1, so it's 64 plus the 32 is on, 32. So 64 plus 32, and of course this one equals, say equals 96, and then I'll also say equals little a, and up here equals 65 equals big A. All right, all right. Now, by the way, if I wanted to, I could have this do the number, let's just say, I don't know, I'll say 1, 2, 3, 4. How about that number? Could I do it with that? Of course I could. Instead, now though, I'd have to double the 128 to go to 256 on the left of it, and then double the 256 to go to 512. Okay, so then I'd say, can 512 go into 1234? And then take the remainder. Can 256 go into whatever that remainder is? Assuming it could, then I'd go again and then try and try. But at some point it would be 0 at the end. All right. Okay, so I'll stop there just so I can explain that. So that's sort of explained, but I didn't want to spend all that time on that, but I'm going to show you now on the internet. So little a in ASCII. Okay. So here is a chart extended table. Let's take this one and see. It doesn't matter. Actually, I'll take this one. Looks like it's bigger. Okay, so I said a big A. Where am I? A big A is a 65, a little a is a 96. So big, so you see these are the numbers. I'm going down the decimal numbers here. So, wait, where the heck is it? Oh, okay, it's going down more. All right, so 65 is a capital A right here. Okay, 65. Now 96. 97 is a little a. All right, so 97 is a little a. All right, so let me change that now. So I'll go back to that document over here. So now it's 97. Okay, so the 64 went into it, yes, one time. The 32 still went into it one time. So there's 96, but there's one remainder. What does that mean? This last 0 is a 1. And so it's going to be 64 plus 32 plus 1. And that's, of course, now going to be equal 97 equals a little a. Okay? That's what your computer can do in seconds as you're typing thousands of characters. Okay? And everything on everything on your keypad is all these stuff. Everything. All right? Colon, semicolon, less than. They all have a representative ASCII code. The number 9 is a 57. You want to do number 9 real quick? Sure, let's do number 9. 57. Where's my little thing? 57. So, and I'll put up here then, 9 equals 57. Okay. So then here, I'll put for 9 equals, so it'll be a 0 for the first, 0 for the second, 0 for the third, 0 for the fourth, because 128 cannot go into 9 one time. 64 or more. 64 cannot go into 9. 32 cannot go into 9. 16 cannot go into 9. The next one can. The next one is 8. So 8 can go into 9. How many times? 1. What's the remainder? 1. So then it's again a 0, 0, and a 1. And then down here, I would put 0, 0. One more. Try to be consistent. 0, And then this 8, see this up here, it shows 8. That's the one I'm taking. 8 is less than 9, so 8 goes into 9 one or more times. So this is a 1, and now the remainder is 1 again. And the remainder is not always 1, by the way, but whatever the remainder is going to be, at the end of doing zeros and ones, it'll always be 0 at the end. 1, and then here we shall say 8 plus 1 equals 9. Oh, wait. Equals 9. Well, yeah, it does equal 9, but also because that's the number we were looking for, so equals 9 again. Okay. All right, anyway, that's enough of that. All right, so that's that stuff there. Don't really need to worry too much about that, but that's computer hardware. That's at what we call layer 1 of the OSI model. OSI stands for Open Systems Interconnect model. And that model shows us what or how basically computer networks work. Okay, everything starts at layer 1, which is the physical layer, and at the physical layer, everything is ones and zeros. And then it moves up to a network layer, moves up to a transport layer, moves up to a communication layer, and it finally moves up to the keyboard, what we're actually seeing. The screen. Okay, so anyway, that was more or less that. Categorize various types of computers, computer hardware, but instead of here, again, let's just go over now to the big book, right? The full book. We'll go to module 3 in the table of contents, right? So 1, 2, 3, computer hardware, and we'll make this full screen because we don't need the other side now. And instead of going through all them, even though I suggest you do, let's go start at the summary, okay? So summary, in this module, you've learned to categorize the various types of hardware, computer hardware. Computer hardware includes the CPU. The CPU is considered the brains of the computer, okay? Memory. Everything on a computer has to be loaded into memory to be processed, to be able to be viewed, okay? But if your computer shuts down, that memory is gone, all right? And this is called random access memory, RAM memory. And RAM is not saved. So if you turn the computer off, whatever you had in RAM memory is gone. So what do we do if we're working on a document, we're working on a spreadsheet, we're working on a PDF file, we're working on an online form, we're working on whatever the heck we work on, we're working on a program. Like I'm teaching C++ this term. So, my students are working on programs. So they have to save their work into what we call secondary storage, okay? Input devices. Again, I mentioned the keyboard for sure is the most common, but a lot of people import files that can then be input. Like if I'm creating a database, all right, in Microsoft Access, I can use an Excel file as input, so as an input device to a Microsoft Access database, and it could be a SQL Server database, it could be an Oracle SQL Oracle database, any database, okay? And again, output printers, output monitors, things, screens, that. All right, and of course, virtual memory. All right, so in addition, you learn about processor logic and the 4 steps in the machine cycle. So fetching, decoding, executing, and storing. That's just talking about how information is gotten to your screen, okay? You learn that computers represent data using binary, which is zeros and ones. It's commonly called the base 2 system. What do you think our system is? Ours is the base 10. So what numbers are in base 10? From 0 through 9. And then there's the base 16 system. The base 16 system is 0 through 9 and then A through F. So let's go back to that little text file here. And I'll say base 2 number system equals zeros and ones. Okay. Base 10 number system equals 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it ends at 9, but it starts at 0. That's why it's base 10. Okay, and then base 16 hexadecimal system equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then capital A, capital B, capital C, capital D, capital E, capital F. Okay? So that's base 16. They're the three numbers systems used. Let me make this a hair wider so that F will go back. All right. All right. None of this, for you guys really matters or means anything. But of course, you have to pick up enough out of here to be able to do well on your quiz. All right. All right. So let's see. We were talking about that. And then we said, so then the various types of computers. Well, all in ones. That means everything is in one piece. Okay. All in one. Everything is in one piece. So if I go over here where I had the ASCII code and I now go all in one computer, all in one computer. And this is an example of an all-in-one computer. So instead of having a separate case, a separate whatever, everything, this is everything, all in one, okay? It may look like just a monitor and it may look like just a keyboard, but everything is stored within it, okay? Everything is stored within it. Now that's only one example. Let's go back here again. This is, again, same thing, okay? That's all in one. So this is what you would get, and that would be the computer, but it's also everything. All right. All right. And then others, in case you're interested in that kind of stuff, and you can search and look at what your choices are. All right. So that's all in one. Go back to where? MindTap. Where am I? On one. Okay. So mobile devices, of course, your mobile devices, your phones are mobile devices, your iPods are mobile devices, anything that's small. Obviously, laptops. Surface is another type of like an iPad, a Microsoft version. So that's that stuff. And then storage. Storage, where do we store everything? Well, I mentioned that RAM, random access memory, is used to run everything that we're doing on our computers. But once the computer is off, or once you close that application, the RAM is gone. RAM is not permanent storage. It's only used to run what you're doing on the computer. But when you want to save it, you have to save it to what we call secondary storage. Okay, secondary storage, again, for the most part, it's probably jump drives, or it used to be at least jump drives. But before jump drives, there were CDs, well, actually DVDs, and before DVDs, CDs, and before CDs, there were those floppy disks. Okay, floppy disks. And these days, though, a lot of people use Box. They use Dropbox. They use the iCloud, right? They use OneDrive. They use Google Docs. They use all these online cloud storage places for storing information, okay? So cloud-based storage is big. Input and output devices are common types of hardware. Types of input devices discussed include keyboards, for sure. Oh, of course, a mouse, right? Pointing device. Touch screens, meaning, like a kiosk as an example. Also, some tablet computers are touch screen. But kiosks for sure. And then pen input devices, they're used commonly on things like a Surface computer. Cameras can be input, right? You upload a camera picture, and that's input. Scanners, game controllers, and even microphones, right? So all that. Output devices, again, the most common, monitors and speakers, but you can also have headphones, projectors, monitors, I said, and printers, but also obviously speakers, headphones, projectors, and voice output. All right. So this module also discusses steps required to maintain and protect hardware components for various types of computers. All right. So that's basically this chapter. But now let me go back to, where was I? Let's see, get out of that part again. Go back to, oh wait, shoot, I wanted the full book. And I wanted it to expand it. Sorry, I wanted to just go down to the key terms now. So the key terms for number 3. And I got to be cognizant, it's already 28 minutes. So I'm not going to, again, I'll just show you and then you obviously go. So that's the summary, but the summary you should always review first. Always, summary first, key terms second, and then you go through the material. So summary, just looked at. Key terms. And a lot of these key terms are going to be, the same for different things, okay? So all-in-one computer, well, you just saw an all-in-one computer, but let's see what their official definition is. It'll be one sentence. Similar to a desktop computer, but the monitor and system unit means case, are housed together, okay? ALU is called an arithmetic logic unit. And these arithmetic logic units do all the math. Anytime you're doing something, if you open up your calculator, okay? If you open up a calculator, the ALU does the math for us, okay? All right, ASCII is, really we call it ANSI, the American National Standards Institute, but ASCII is, you know what, I forget what ASCII stands for, CII, but I told you how you do the code on ASCII. That's where I went with the zeros and ones. American Standard Code for Information Interchange, but this is where, you know, similar to the site I pulled up a while ago, it actually may even have been this site, where it's showing you the decimal values, okay? It's showing you the octagon, the hex, the binary, BIN stands for binary symbols, but basically what we wanted to do was find out what these numbers represent, you know, and like the number 50, the number 65, I specifically said is a uppercase A, and then they go through all the other uppercases, and then there's a few more, and then it starts the lower cases. So all of these things, it's ASCII. Okay, ASCII is the official language, so to speak, for it. So American Standard Code for Information Interchange. Remember, you can jot down notes to take your quizzes. All right, anyway, that. Back over here. So benchmark. Benchmark is like a standard. You know, you're trying to do something. So tests run by laboratory to determine processor speed and other performance factors. But you're trying to get the standard, what you're trying to achieve, or what that particular device should achieve. Okay. Binary system is the zeros and the ones. Okay. A bit is 1/8 of 1 byte. So a bit is the smallest unit of data a computer can process. It can't store it as a bit though, because it takes 8 bits to make 1 byte. In other words, you can't put 0, like remember when I showed this again over here? So see this, there's 8 bits, okay, which makes 1 byte, and the 1 byte is this. Oh, and by the way, let me also show one more thing just out of curiosity here. So 1 byte equals 8 bits. What's the next smallest storage past byte? It's kilobyte. 1 kilobyte, okay, equals 1024 bytes. That means, which is 2 to the 10th power. Okay, so what's 2 to the 10th? Well, simple. You go 2, you double it. Let me go down in one spot. 2 doubles to 4, doubles to 8, doubles to 16, doubles to 32, doubles to 64, doubles to 128, doubles to 256, doubles to 512, doubles to 1024. Now count those that I just did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 to the 10 is 1024 bytes. Watch this. This is going to be 2 to the 20. So 1024 equals 2 to the 10th. If I was on Word, obviously, I could go ahead and just do the superscript and subscript to make my 10 go up. But anyway, that. So then if I want 2 to the 20, I have to then, so the next one's 11. This is going to be tricky. 2048, because it's double 1024. What's not double? 4096. Some of you are pretty good at math and probably do this. What's the next one? Well, let's see, 4, that would be 8. 96 twice is 192, so it's 8192. Next one, 16, and then it's 8 less than 1, and you got another 8 is 16, so it's 16 less than 400, so 16, 3, 8, 4, the way I count. Next one, 32, 6, which now turns to 7, and the 8 goes to 6, and the 4 goes to 8, 68. I may be wrong, but I'll look at it in a minute. All right, so that's that one. Now they get tricky. So 64, but this is going to be 65. The 7 becomes a 4, but it's going to go up to 5, so it's going to be 5, because the 6 and 6 will go to 20, and then 36. I think it's 36 that way. Okay, and I may be off slightly, but either way. All right, then what does that double to? So, well, where am I? So this is 2 to the 11, 2 to the 12, 2 to the 13, 2 to the 14, 15, 16. I want to just go to 2 to the 20. All right, so so then I've got 130, but it's going to be 131 because I got a 5. And then, oh, that'll be easy after that. So 131, wait, 10, 131, 172, I think. Okay, and then what does that double to? So 2, 6, 2, and then 3, 4, 4. Okay? And then what does that double to? 5, 24, 5, 2, 4, 6, 8, 8. And what does that double to? 1, 0, 4, 8. But that, because of the 6, will go to 9. And the 6 will go to 20, which will go to 3. So it's going to be 3. Let's see, it's going to be a million. So 493. Oh, I can't do the rest, but 88 and 88 anyway. 160, 176. Something else, I'll just put 2 and then 176. So what is that? 1 mil, 049. No, I don't need those. I'll just say 376. And it's something like that. Okay. Now, that's 2 equals 2 to the 20th power. I want to actually see that now. So this is called a megabyte. So this is a kilobyte equals 1 kilobyte. And then after a kilobyte is a megabyte equals 1 megabyte. All right. So megabyte in bytes I'll put over here. So now megabyte in bytes. They're rounding it. It's not a million. Oh, there it is right here. 1048. So let me copy that. Control copy. Go back to mine. I honestly did not plan to do this, just to let you know. Go down one more and see. 1048576. So I was off by an even kind of a number. So 148.5, that brings us to 424, 724, 8. I was off by exactly 800. So one little calculation was off by one stupid digit. Anyway, but so 1048576 bytes is 1 megabyte. All right, that's how things work in computers. It's all easy. All right, over here. So clock speed. Of course, clock speed, we're talking about the speed of our devices. Everything is measured these days in gigahertz. In this definition, they're saying megahertz, but everything these days is gigahertz because obviously computers are changing all the time. Cloud storage, we just talked about the iCloud. We talk about Google Cloud, talk about OneDrive, talk about Dropbox, talk about Box. So storing electronic files on the internet, not on a local computer. So that means you're in the cloud. Okay, control unit manages the flow of instructions within the processor. So a dance pad. I don't know a dance pad. Game controller that is. I don't play games, so maybe you guys know that as that. So if you do, good. If you don't, you got to look at it. But you can look then at the rest. Okay, external hard drive. Obviously, that means it's a hard drive that you're connecting to your computer. And normally these external hard drives hold in the neighborhood of, in the old days, it'd be 300 or 400 gigabytes, but these days they're up to the terabytes. So probably at minimum 1 terabyte, possibly 2 terabytes, and they're hooked up via a USB cable. Okay. Firmware is instructions on a ROM. ROM stands for, let's see, random access memory, ROM. What is ROM? Random access memory, ROM. Read-only memory. Yeah, read-only memory. Okay. So, but anyway, you can go through those. So that's this chapter. All right. But make sure you go through it. Jot down any notes that you need. Then let's go to chapter 4. And we'll have to go a little faster, and then 5. So 4 is operating systems and file management. So again, you should do the same stuff. If it's a video, you can just watch it. This is saying comparing operating systems. So they might be comparing a Mac with a Windows computer. Who knows? Might be comparing a Linux operating system. Okay. Against a Unix operating system, against a Windows operating system. Who knows? But it could be any of those things, all right? And then how operating systems work. So it's all operating systems here. And then again, this quiz. So let's go over to the book, and we'll go quickly to chapter 4 in the table of contents and operating systems, file management. Open this one up, and let's go straight, in this case, again, the summary. So the summary, you see, it's only a few pages or a few paragraphs. In this module, you learn that system software. So there's two kinds of software in computers. System software runs the computer itself. And then there's application software. The application software are things like the Word files, the Excel files, the PDF files, the PowerPoint files, CPP files in my C++ programming class, where CPP stands for C++. So operating system is the system software that really runs the computer, the operating system, the utilities. So the operating system manages the complete operation of your computer. Operating systems come in three basic types. We know about desktop operating systems, server operating systems. So a desktop is used by us. A server operating system is normally used by a company or cloud providers, where the server has the programs that we're going to be using, okay? And then, of course, mobile operating systems. They just say your phone for that, right? Every programmer app requires RAM, right? That's the random access memory. And this is the one that's volatile. I said it doesn't save. It means when it shuts down, volatile means when it shuts down, it's over. It doesn't save, okay? And then you're saying you can customize elements of system software. Fine. Brightness, resolution, adding a theme. Yeah, of course we can. You can use the operating system to customize your hardware, such as the keyboard or pointing device. Of course we can. Operating system. So operating, they're not even talking about applications here, just strictly operating systems. All right. So that would be that. Now let's see if I can go back and find the other part. No. How do I do it again? I got to start again at that chapter. Click. Then go to the key terms. Okay, so you have more or less again 20, probably 50 of these definitions. Okay, but you can look at those. In this class I've talked about virtual memory, virtual machines, because that's what you use. I said when you go to the MindTap site. So what's a virtual machine? Enables a computer or device to run another operating system in addition to the one installed. So for those of you using a Mac, all right? For those of you using a Chromebook, when you're on this MindTap site, and if you're specifically on any training, if the training is on Windows 10, your Mac is running a virtual machine. It's a Mac computer, but it's running, it's what we call emulating the Windows 10 operating system in a pop-up window. Okay, that's the way that works. So virtual memory, though, is when you're using information temporarily in what we call paging files. It's sort of like lets you have a little bit of a buffer, a little bit extra memory. If your computer can't run extra things, if you create virtual memory, then you basically can improve your ability to run programs maybe by 10 or 20%. So virtual memory, amount of information temporarily stored in what we call paging files, okay? Volatile memory is RAM. This is memory that is temporary, loses its contents when the power is turned off. They're not putting RAM, but this is RAM. Very important to know, RAM, random access memory, okay? Web app, obviously, any app, meaning any application on the internet. So an app stored on an internet server that can be run entirely in a web browser. Windows. So Windows Server is Microsoft Server operating system that includes advanced security tools and programs called Internet Information Services that manage web apps and services. But it's a server for Microsoft operating systems. Okay? Windows obviously is your operating system. So the operating system for Microsoft machines. Web app. We said web app. I said volatile memory. Virtualization. Virtualization is when we're wanting to go ahead and practice, or we're sharing our resources. So when you are running things in a virtual machine like MindTap is doing for us, there are thousands of people, not in my classes, but in the whole country and in the whole world, there's probably at least tens of thousands, if not hundreds of thousands of people that are sharing computing resources based on virtualization, based upon what the class is running. All right, so it's a lot of stuff, User accounts, all the accounts for the computer. So identifies the windows, the resources such as apps and storage locations a user can access when working with the computer. In my computer, look at what I do to get to where I want to go. This is what I do. So like if you look at my desktop, there's my desktop. That is my whole desktop. Watch. Show. That's it. Oh, there's that that video I was playing. It was still there. Okay, so you see my desktop, very, very, very clean. I have very little things on it. Okay, where do I go? Look what I did. I created a little shortcut to where I put all my stuff. It's on my C drive. Okay, so look at my address now. It's this PC, then it's Windows C, then it's users, and then it's my user name for this computer, J Mallow, and then this is my desktop. So it's like it's in effect, I'm creating a virtual machine in effect here that I'm accessing from the regular desktop. But in this one, I now have my pictures. Okay, so like, let me go back to the other again. So go back to just this computer, so desktop, right? And here's pictures. Watch the pictures. There's nothing in it. See, there's nothing in my pictures. If I go to here, there's nothing there. If I go here, there's nothing there. Now watch where my pictures are. I can go from this shortcut, so desktop, and then click my shortcut, which is where I just went, but I'll do it this way. This PC is the manual way to do it. Then Windows C, then users. Remember I said then J Mallow. Now I look for pictures. There's where I put my pictures. Okay? And the one that you're looking at there on my desktop is this one. Okay? The one that you see when you're looking at me on some of these things I'm doing is this one here, John Coffey, March 2021. But anyway, so that's that stuff, right? Not that that really matters. Here again. All right, so, but user accounts dictate what you can do. Unix is an operating system that is like a competitor to the Microsoft, the Windows operating system. This is the one that Macs use, all right? So Apple uses Unix, multitasking operating system with many versions. And then there's Linux, which is a flavor, just a little, like a subset, so to speak, of Unix. Unix is a huge one, but it's Apple that gets to use it. Linux is similar to Unix, and there's a whole bunch of Linux operating systems. So if you click on all these, or just perhaps look down, so Wind River is an OS, okay? This is the little Linux icon. Red Hat is Linux. Anyway, there's a whole bunch. In the old days, I used to teach a lot of that stuff in my networking classes, but I don't teach as many of them anymore. So that, and that is enough of that. Okay, so back over here. So anyway, you know, just look at the little, the clickers here and click on what you think you might need. Shortcut, I just showed you a shortcut, right? Link to a file, folder, or app that appears in the desktop. Right here, shortcut. Let me get rid of the shortcut and I'll show you how you create one. So I'll delete it. I'll just delete it this way. Delete, it's gone. Now I want to create a shortcut. So I right click and I go to new and I want a shortcut. And then I browse to where I want my shortcut. So this PC, then I want to go into Windows, the C drive. I want to go into the users. I want to go into my user. And then where do I want to set it? Oh, I need to end this soon. I got a convocation debrief. That's right. Okay. And I want to go to J Mallow and then show all the J Mallow stuff. So here, if I say OK and I say next and I say J Mallow, profile storage and links. Okay, so right there, if I click it, then that's as far as I went. But now there's my pictures again. If I click on pictures, they're here. If I click on my desktop, this is the way I'm using the desktop. This is now this desktop, a lot more stuff in it. And this is where I store all my work files. Okay, anyway, all right, that. So, but that's enough of that one, but they're all again similar. Okay. So server, operating system, settings, app, obviously nice and easy. Resources, things you're using in your computer. Pointing device, you know, obviously a pointing device is when you're using, you've got your mouse, it's a pointing device. They're specifically saying hardware device lets you interact with your computer by controlling the movement of the mouse pointer. So it's just, you know, it's called a pointing device. A lot of people, of course, me for sure, call it mouse. You go up here though, you see, you know, mouse is not actually listed. Non-volatile memory, by the way, is secondary storage. This is where we're saving files. Okay, so we save it, when I mentioned, to a jump drive or to the cloud. This is not volatile memory. This is secondary or permanent memory. Okay. All right. Open source is free stuff, things that you can use, you can download, use, you can even modify. Okay, so programs and apps that have no restrictions from the copyright holder regarding modification and redistribution. All right. Minimize button, obviously we all know that. Menu, we all know what a menu is. See what they're saying for it. List of related items, including folders, applications, and commands. Megabytes. This is that one I just demonstrated. It's millions. It was 1048,576 or so. 1048,576, and I got it as 1049,376. One darn. If this 3, if I added 8, took away 8, sorry, it came to this one. Anyway. All right, so that's that. I really got to end this, so I may not even touch on module 5, but let's at least try. So software and apps is module 5. Go over here to the full book again. Module 5, table of contents. Whoops, open big. This one I'll just go straight to the, no, I'm just going to again go to the end though. It's, oops, wait, where am I? Wait, what's going on? Table of contents. Software and apps. Okay. So there, again, you can read it. Summary. Because I have to get on another call. So in this module, you learn to name, visually identify, and describe popular productivity apps, including word processing, spreadsheet presentation, and database software. So in our class, the word processing will be Word, the spreadsheet will be Excel, the presentation will be PowerPoint, and the database will be Microsoft Access. You'll learn about that software and their key features. You also learn to describe different types of application software. Application software is user software, right? It's like business software. So graphic software, drawing apps, paint apps, photo editing, all these things are software. Productivity apps are used in both personal and business settings. Types of productivity apps discussed include word processing, spreadsheet, presentation, database. All of these things come with Microsoft Office. And when it's that's called a suite, S-U-I-T-E, but the suite includes Word, it includes PowerPoint, it includes Excel, and it includes Microsoft Access if you have Pro Plus, unless you're running Pro Plus, meaning Office 365 Pro Plus. But if you're running it on a Mac, you don't get the database. You don't get Microsoft Access because Microsoft and Apple could not agree on how much Apple should have to pay Microsoft to get that software. All right. With word processing, you can format text, documents, manage documents. With spreadsheet, you can create, manage workbooks, analyze data, create. This is what this whole class is about. All right. So pay particular attention in chapter 5 here. Database programs, you can create data sheet tables. I'll be doing a big, over a 1-hour demonstration showing you guys how to create a database, even though in this class I told you you won't be doing projects in Access, but you'll be doing some training for sure, and it's a hard subject. So that's that stuff, all right? So let's try to get 3 minutes. Oh, darn it, I did it again. Let me get 3 minutes on the terms, and then I have to go. Terms, 5. Okay. Key terms. All right, so absolute reference is it's in Excel, and it's a reference to a specific address, a cell reference in Excel. A cell reference that does not change when the formula containing the reference is moved to a new location. Okay. Animations, obviously, you're just adding animations in, well, specifically in this chapter, I guess, because they're talking really, they said software application. So PowerPoint, an effect applied to an object that makes the object appear, disappear, change, or move. A lot of you guys do a lot of stuff, I'm sure, with PowerPoint. Apache Open Office is a competitor to Microsoft Office. So it's an open source suite of productivity apps. An app, again, we saw this in a different chapter, but it's a program, right? It's an application. So app and application are the same. Apple iWork, now you're talking about productivity suite, but specifically for the Mac. So when you're on your Mac, and if you have iWork, then you're using the Apple's version of Microsoft Office 365. The Microsoft one is the original. It's what it amounts to. Apple, Apache, right? Google Docs, they're all competitors. Application software are programs that help you perform specific tasks. Again, these are for personal, also for business use. Argument is something that if you're using information when you're creating a formula, an argument would be something within an open and closing parenthesis to create a function. Okay, so it helps us get an answer. You'll be learning and hearing me talk about arguments in Excel. Okay, we then go down. Well, so cell in Excel, it's a cell. It's one spot. Box formed by the intersection of column and a row. A cell address, cell's location expressed by its column letter and row number. In Excel, there literally are tens of thousands of columns and rows. So therefore, hundreds of thousands of cell addresses. Okay. Charts you add into an Excel file represent some data. You use bar charts, column charts, among others. Right? Clip art you can use to insert little pictures into your electronic documents as well. So all of these formulas, you use formulas in Excel, and the formulas are allowing you to do math with numbers, right? Function is a named operation that replaces the action of an arithmetic expression. So in Excel, you'll have an auto sum function. You'll have an if function. You'll have a what's it called? You have an average function. You have a payment function. You have a lot of functions, okay? A G Suite is another one of those. This is Google. I say Google Docs, but now they call it the G Suite. So Microsoft Office, and then there was the Apache, and then there's the iWorks and G Suite. They're all the same, but they're all based on Microsoft Office. Microsoft Office is the original out of all that, okay? So all of these you can go ahead and keep clicking on. Make sure you get some information for yourself. Now I've got to go to my meeting. You guys have a great day. I'll see you when you're in class with me. It'll be on the first day of September, September the 1st. Have a great day, everyone. Bye-bye.